going to share the PPTs first as a convention, and I would request to all of you, please mute your mics and also pin my pic so that you would be able to see the presentation. I hope the PPT is visible to all of you. Ajay sir, PPTs are visible?
Yes, ma'am.
Okay, thank you so much, sir. So now we are starting with the independent sample t-test first. Agenda for the day is we will discuss independent sample t-test and its assumptions, and then Mann-Whitney test along with its assumptions. And all the assumptions we will check in the case of both the tests. So firstly, I am discussing the independent sample t-test. So in the other name for independent sample t-test is two sample t-test, or you can say it's a student's t-test. It is basically a inferential statistics, as we have discussed on the second day of FDP about descriptive statistics. Then we have discussed that statistics has two categories: descriptive statistics and inferential statistics. So in inferential statistics, we generally keep the t-test, ANOVA, etc. So t-test is a inferential statistics. So with the help of these tests, we try to predict or infer the population distribution or population mean with the help of this test. So with the help of this test, we can make a hypothesis like there is a statistically significant difference between the means of two unrelated groups. Now, what is the unrelated group? Unrelated groups are those groups are unpaired, or you can say when the participants of one group are not the part of the other group, means both the groups are independent in nature. For example, suppose gender is a variable. Gender is an independent variable and it is divided into two groups, that is male group and female group. So the participants of male group, means those respondents who are male, they cannot be the part of female group. So this way these both the groups are independent in nature. So that is the meaning of independent sample t-test. Now, which type of variables are needed for independent sample t-test? Firstly, we need one dependent variable, and we need to measure this variable on continuous scale. That means either on interval scale or on ratio scale. So we should have one dependent variable and we have to measure that variable on continuous scale, means either on ratio scale or on interval scale. Second, we should have one independent variable, and the nature of independent variables should be categorical, means we have to measure independent variable either on nominal scale or on categorical scale and there should be two levels of that particular variable. So again, I'm taking example. For example, gender is an independent variable. So gender is a categorical variable, first thing. Second, we can classify gender into two categories, that is male category and female category. So this way you can say that gender is an independent variable and it has two labels, that is male and the female. Other example, if I want to take, other example can be the occupation. If you are asking the occupation of your respondents, so suppose there are only two categories, that is business class respondents and the respondents who are working in the service industry. So this way you can say that occupation is an independent variable and there are only two levels, that is business level and the service level. So this way we have to understand the independent variable. Next, when we are talking about the sample size for t-test, generally, as all we have studied in our MBAs or in some other subjects, that generally when we apply t-test, when the sample size is less than 30, in that case we apply t-test. When the sample size is greater than or equal to 30, we will go for the z-test. But when we are talking about SPSS, SPSS gives you the t-test only. So for that, it means if we have if we have sample of any size, we can perform t-test, because in statistics this is the assumption, when we increase the sample size, generally the distribution of the data will be normal. So if your data is showing normal distribution, you can apply t-test, and the large sample size, that scores of or the results of t-test and z-test are more closer to each other. That is the main thing you need to keep in mind. That means if you have sample size greater than 30, even then in that case you can apply the t-test with the help of SPSS. Then the hypothesis of independent sample t-test. Here you can see there are three ways to define hypothesis of independent sample t-test. The first way is, in the first way you can see it is written, the null hypothesis is mu1 is equals to mu2. It is indicating that the population mean of first group is equal to population mean of second group. So you can say this is the null hypothesis. Alternatively, you can say mu1 is not equal to mu2, means the first group mean is not equal to second group mean. And when you are stating the alternative hypothesis is not equal in non-equal to form, in that case there are two tails involved. Means here we are stating that mu1 is not equal to mu2. So in other way we can say mu1 can be less than mu2 or mu1 can be greater than mu2. But we are not sure whether the mean of first group is less than or greater than to the mean of second group. That is why this is known as the two-tailed test. Second type of hypothesis is when you are clearly stating that the group mean of or the first group mean is greater than and equal to the second group mean, and in alternative hypothesis you are saying that the group mean of first group is less than group mean of second group, then you can say this is a one-tailed test. And when you are clearly saying that the first group mean is less than second group mean, then that is the left-tailed test. Third one is when you are saying the first group mean is less than or equal to the second group mean, and alternatively you are stating that first group mean is greater than second group mean. That means here again you are clearly saying that the first group mean is greater than second group mean. So that is why there is only one tail is involved, and you can say this is the one-tailed test. And when your first group mean is greater than second group mean, then you will say this is the right-tailed test. Graphically, I am showing you when you are framing your hypothesis like mu1 is equal to mu2, and alternatively if you are saying mu1 is not equal to mu2, means when you are making your hypothesis for two-tailed test. So this is showing you the normal distribution curve, and according to this curve the white area is indicating you, this distribution is indicating you that the white area is saying this is the non-rejection area of the null hypothesis, and the dark area which is the red area, you can see both the side, both the tails are involved here. So this area is indicating you this is the rejection region. Means if the calculated value of the t-test is fall in this range, means if t-test value is coming this side or this side, so we will reject the null hypothesis at 5% level of significance. This is according to two-tailed test. When I am talking about the one-tailed test, here you can see mu1 is less than mu2. That means this is the left tail test, and the rejection region will fall on the left tail. Remaining white area will be the non-rejection area. Means the if the calculated t value is falling somewhere here, so you will not reject the null hypothesis. But if the calculated t value will fall somewhere here, you will reject the null hypothesis. So this is the left tail test. Similarly, you can see this is the right tail test right tail test diagram. In this particular diagram, you can again see that this white area, this is the non-rejection area, and this area is stating you that you are rejecting the null hypothesis if the independent sample t-test value will fall somewhere here. So this is the rejection area for the independent sample t-test. So we can say, previously I have shown you the hypothesis in the symbol form. Here you can state the hypothesis in the word form. In the first case, you can say there is no significant difference in the group 1 mean and group 2 mean. Remember, the hypothesis is mu1 equals to mu2, means both the groups mean are same. So in the word form, you can write there is no significant difference in the group 1 mean and group 2 mean. For the second type of hypothesis, that is for the one-tailed test, you can frame your hypothesis in the word form like group 1 mean is significantly less than group 2 mean. That is the left-tailed test. If your if you are stating the hypothesis for the right-tailed test, you can write the hypothesis in the word form as group 1 mean is significantly more than group 2 mean. So this way you can frame your hypothesis in the word form. One more thing, if your hypothesis in the symbol form, that is mu1 is equals to mu2, so this you can write as mu1 minus mu2 is equals to the 0. So means if you are writing your hypothesis like this, one in the same thing, you can write this or this, both are stating the same thing, that there is no significant difference in the both the groups mean. Alternatively, you can write mu1 is not equal to mu2, or you can write mu1 minus mu2 is not equal to 0, means there is certain difference exists between the group means group score means of the two groups. So this way you can make your hypothesis. Next, when you are going to calculate independent sample t-test manually, so you have to follow certain steps. First step is you need to define the null and the alternative hypothesis firstly. Then you need to set the alpha value, and alpha value is the level of significance, means at what percent you will check the results, that you need to clearly mention that at 5% or at 1% you are stating your results. Then you need to calculate the degree of freedom, and for calculating degree of freedom the formula is n1 minus 1 plus n2 minus 1. Here n1 is the sample size of first group, n2 is the sample size of second group. Means if you have two groups, male and female, so what is the count of male and what is the count of female, that you need to take here and then subtract 1, and then you will add to get the degree of freedom. This is the way of calculation of degree of freedom. Second, you need to state your decision rule. So suppose this is the thumb rule, you need to know this, that when the calculated t value is less than tabulated t value, then you will accept the null hypothesis at 5% level of significance, and for whatever degree of freedom you are getting from the calculation. That means this is the thumb rule, and vice versa. If the calculated t value is greater than tabulated t value, then you will reject the null hypothesis. So this is the thumb rule, and please keep in mind this is for the manual procedure, because when we will go for the SPSS calculation, the results will be just reverse, or the interpretation will be just reverse. Then next is calculate the test statistics, means we need to now calculate the t value. So the formula are first one is t is equals to under root of x1 bar minus x2 bar divided by sp square in brackets 1 by n1 plus 1 by n2, and this is the degree of freedom. This and this both are the same thing. If you will simplify this degree of freedom formula, you will get this n1 plus n1 minus 2. So here x1 bar is the mean of the first group, x2 bar is the mean of the second group, n1 is number of observation in first group, n2 is the number of observation in second group, and sp square is the pooled standard deviation, means you have to merge both, the means you have to calculate the merged sample or merged standard deviation, and for calculating that formula is n1 minus 1 into s square plus n2 minus 1 into s square whole divided by n1 plus n2 minus 2. So this way you can calculate the standard deviation or pooled standard deviation. Here S is the standard deviation of both the groups, means when both the groups, male group and female group, has same standard deviation. That is why here only S is written. Otherwise you can write S1 square or here you can write S2 square, and that would be the different case, and in that case you will calculate SP in a different manner that I will show you now. So the second formula is this: when the standard deviation of both the group is different, means for male group you are getting different standard deviation, for female group you are getting different standard deviation, then in that case this would be the formula of calculating T, and this would be the formula of calculating degree of freedom. Means in the previous case the formula for calculating degree of freedom was n1 plus n2 minus 2 only, but in this case when the standard deviation for both the group are different, in that case this particular formula will be changed, and this will be applied to calculate the degree of freedom. So this way you can calculate the t value of independent sample t test, and then you need to state the results, and state the results means you need to compare here the tabulated and the calculated value, and then you will state the conclusions on the basis of your comparison. So in the next slide you can see this is the standard t table, means when you are going to calculate independent sample t test manually, so you need to look the standard tabulated value of t, and suppose if for example you have calculated t value and suppose you are getting 1.78 at 5% level of significance and for 12 degree of freedom, so in that case what you need to do, you need to here check the tabulated t value. How you will check the tabulated t value? With the help of these two parameters, that is the level of significance and the degree of freedom. So here you can see one tail and two tail test is written, means accordingly you need to check, accordingly you need to select the degree, level of significance, and here degree of freedom is listed. So degree of freedom is 12, so degree of freedom is 12, and suppose level of significance is 5%, and we are checking for the two tail test. So you can see this is the tabulated t value, that is 2.179. Now you have to compare 1.78 to 2.179. So with the help of comparison we can say that calculated value is less than tabulated value. If calculated value is less than tabulated value, in that case we will, or we have to accept the null hypothesis. And what was the null hypothesis? That there is no significant difference exists between the two groups mean. So this way you can conclude your results. So this is the manual procedure of calculating the independent sample t test. Now if you are calculating sample, means whenever you are calculating independent sample t test either manually or with the help of SPSS or any of the software, firstly you need to check the assumptions, and assumptions are, first one is the independent variable should be categorical. That means it should be measured either on nominal scale or on ordinal scale. Then what you need to keep in mind, there should be two groups available for the independent variable. Then dependent variable should be continuous in nature, means we have to measure dependent variable on continuous scale, means either on interval scale or on ratio scale. Then independence of observations. So the meaning of independence of observations is, that means the categories you are taking for your independent variable, those categories should be independent to each other. Means as I have told you when I have given the example of gender, so we have taken two categories, that is male and female. So both are independent to each other. Means male, if your respondent is male, so he will be the part of only the male category. He cannot be the part of female category. So this way the observation will be independent to each other. Then the dependent variable should be normally distributed in both the groups. So this is the important assumption. That means The dependent variable which is on continuous scale, it should be normally distributed for both the groups. Then independent variable has no significant outliers in either group. Means when we are talking about the dependent variable, so it should not contain any outlier. If we are talking about two groups, male and female, so in both the groups it should not contain any outliers. That is the one thing. Next one is the variances of the dependent variable in two groups are equal. Means homogeneity of variances should be there in both the groups. Means groups are male and female, so both the groups have same variances. If both the groups are showing you same variances, that is the homogeneity of variance. So these all we will check one by one when we will move towards the SPSS. Next, there is a note: when one or more of the assumptions for the independent sample t-test are not met, we should run the non-parametric test, and that test name is Mann-Whitney test. So means if any of the assumptions is violated by the data, so we cannot perform the parametric test, that is the independent sample t-test, and we need to go for the non-parametric test, and we should select the Mann-Whitney test. Here you can see this is the histogram, because one of the methods of checking the normality is the histogram. So suppose if your variable is dependent variable is showing you this kind of histogram, so this type of histogram we can say that this is indicating you the normally or approximately normally distributed variable. If your variable is showing you such kind of histogram, so you can say that your variable is normally distributed. Then talking about the last assumption of the independent sample t-test, that is the variance of both the groups should be equal. So for checking that particular assumption, we need to apply the Levene's test. Levene's test is the output of independent sample t-test. Means whenever we will apply the independent sample t-test, in the final table of independent sample t-test, we will get the value of Levene's test. So we should not go to anywhere. We need to just check the remaining assumptions, and this assumption we will check with the help of independent sample t-test output, which is given by the SPSS. So for this particular test, the null hypothesis would be sigma 1 square sigma 1 square minus sigma 2 square is equals to 0, and sigma 1 is indicating you the standard deviation, and when we will square this becomes the variance of the first group. So variance of first group is equal to variance of second group. Means when we will transpose this particular term here, so we can write this like sigma 1 square is equals to sigma 2 square. So for Levene's test, the hypothesis is the population variances of both the groups are equal. That is the null hypothesis. And the alternative hypothesis is the population variances of both the groups are not equal. So this way we can check the Levene's t-test. Now when we are talking about independent sample t-test with the help of SPSS, so these are the steps which we need to follow for applying the independent sample t-test. So now I am moving towards to the SPSS window for the exposure of independent sample t-test. So I have opened here a worksheet called employees data. I hope you all have this sheet. With the help of this particular sheet, we will check the independent sample t-test. I think you are aware with this particular sheet because this is already given to you. So in this particular sheet, you can see I'm coming to the variable view. Here there are so many variables available. So for example, as per the independent sample t-test, we need two variables. So one should be on nominal scale and second should be on the continuous scale, that is either on ratio scale or on interval scale. So for the sake of independent sample t-test demo, I am taking two variables. First one is the current salary and second one is the gender. And with the help of these two variables, we are framing our hypothesis. There is no significant difference between the salary of male and female employees. Again, I'm repeating the null hypothesis for this test. There is no significant difference in the salary of male and female employees. This is our null hypothesis. So here you can understand one thing. There are two variables. First one is the gender, means gender is bifurcated into two groups, male and female, and second one is the salary. So gender is on nominal scale, and salary you can see it is measured on the scale measurement. That means it is on the ratio scale. So this way we can say assumptions are met. How many assumptions we have checked? We can come again to the, here you can see we have checked first assumption that independent variable is categorical. Yes, it is matching. Then we have two categories. Yes, it is also matching. Then dependent variable should be continuous. It is continuous. Independence of observations, when we have two groups for the independent variable, means the observations are independent to each other, means first three assumptions we have checked only with the help of observation. Now we have to check the remaining three, not remaining three, only fourth and fifth. Sixth will be the output of the independent sample t-test. So now we have to check the normality of the dependent variable and also outliers in the dependent variable. So again I am coming to SPSS window, and now we will go to check the normality and the outlier criteria for the dependent variable, and here dependent variable will be our current salary. So what you need to do, you need to go to just analyze and then click on descriptive statistics and then select explore. Again I am repeating, for checking the normality you need to go to the analyze menu, then select descriptive statistics and then go to the explore option. Then click. When you will click, a box will appear. Here there are two boxes given to you, that is the dependent list and the factor list. In the dependent list we need to transfer our dependent variable, and in the independent or in the factor list we have to transfer our independent variable, that is gender. So this is we have transferred. Now what you need to do to check the normality, although we have seen this yesterday, so I hope you all have this thing in your mind that how we can check the normality. What we need to do, we need to click on the plots button, and here box plot will give you the outliers exposure, and this normality plots with tests, means this will give you both the numerical and the graphical methods of normality. It will all give you the QQ plot, histogram, as along with the Shapiro-Wills test and the Kolmogorov-Smirnov test. So you need to just click on this, and I am just removing stem and leaf and clicking on the histogram, and then click continue and then OK. As you will click on OK, you will be able to see the output. It is taking, I think, now output is generated. Now you can see this is the case processing summary. It is indicating you how many female and how many males are there in the data set. Then this is the descriptive statistics. We have already discussed this particular thing. Now we need to check the test of normality, that is the Kolmogorov-Smirnov and the Shapiro-Wills test. So according to these tests, you can see generally we need to check the Shapiro-Wills test. This is indicating you the significance level, or this is giving you the p value, that is 0.000 in both the cases, in case of the female group and in case of the male group. Means when we are talking about the salary in context to the female and talking about salary in context to the male, we can check the significance level or the p value. So the p value is less than 0.05. If your p value is less than 0.05, then you need to reject the null hypothesis. And I have told you the hypothesis for these Shapiro-Wills and Kolmogorov-Smirnov is variable is normally distributed. That is the null hypothesis. According to the results, we need to reject the null hypothesis. Means this is showing you that variable salary is non-normal, means it is not normally distributed along the female and the male group. So this is the this is we have checked with the help of numerical method. Now when we are talking about the histogram, you can see here these histograms are also stating that the current salary is not distributed as for the female. This is for the female group, so you can say that current salary is not normally distributed, because I have shown you what how we will get the graph of histogram, means this higher frequency will should be lie somewhere here in middle. In that case, you can say that the distribution is the normal distribution. So this is for the female. Similarly for the male also, you can see this is not the normally distributed. If you want to keep the normal distribution curve on both the graphs, you can double click on this and can select this. This is selected, just close and close and close this. So you would be able to see that again. You can see with the help of this particular bell shaped curve, you can see the tail or right tail is bigger than the left tail. So you can say that the salary for the male group is showing us the positively skewed data. Similarly, when we can go here and can put the normal curve on the same graph. So this is also stating the same thing, that the right tail is bigger than the left tail, and on the basis of this we can say that the salary is not normally distributed in case of female group as well. Means both the theoretical means both numerical and the graphical methods both are stating the same thing. Now box plots. Here you can see box plot for female group, box plot for males group. So in both the box plots, you can see there are certain number of outliers available. So with the help of these outliers, according to the assumptions, we cannot proceed. So what you can do, either you can remove these outliers from your data, or you can proceed further if you are assuming that the outliers are not much in number, not many in number. So in that case, you can go with these outliers. So for sake of demo purpose, even for, when all the main assumptions of independent sample t-test is violated by the dependent variable, even then I'm going to perform independent sample t-test for the sake of demo only. So I'm going to now analyze menu. Then I'm selecting the compare means option. Again, I'm repeating, go to analyze menu, select compare means option, and then in the arrow, when you will keep the mouse on this particular compare means, you would be able to see the options available, and here you can see independent sample t-test is written. So just click on independent sample t-test. As you will click on independent sample t-test, the window will open for you. Now here what you need to do, test variable means this is the dependent variable. We have to shift our dependent variable into the test variables box, and in grouping variable we need to shift our independent variable. So as we are knowing this, that current salaries are dependent variables, so we are shifting this to the test variables box, and gender is our independent variable, so I am keeping this variable here into the grouping variable box. Now when you will shift your independent variable here, it will be shown to you that this define groups button will be activated. Means here you can see there are two question marks, because there can be only two groups in case of independent sample t-test. That is why you can see there are two question marks are here. That means we need to give values here. So what you need to do, you need to click on define groups, and then when you will click on define groups, a small box will appear on your screen. Here you need to define group 1 and group 2. Group 1 is suppose male, I think male is 1 and female is 2. Click continue, And then when you have defined this, go to the options button. Here you can check confidence interval percentage is 95% by default by SPSS. If you want to make any changes, means if you want to check your hypothesis at 1% level of significance, that means you can make your confidence level as a 99%. So it's totally up to you. This there is a you can see there is a facility to make changes in this particular value. So if you want to make change, you can enter value from your keyboard, but I am okay with 95%. So I'm just not making any changes here, just clicking on continue and then okay. As you will, there is a warning. I need to check the variable first. Okay, because in my data set gender is defined as M and F, so I think I need to give the value differently for the same. So again I'm going and repeating the independent sample t-test, and now I am changing the defined groups, and I think suppose one is for, I need to again check this. One is for what? Gender. Nothing is written, only F and M. So I'm just clicking on analyze, then compare means, then independent sample t-test, then coming to the define groups and writing here F and M. Then click on continue and then click on OK. So now you are able to see the output. Now SPSS is giving you output for the independent sample t-test. So now I am interpreting both the tables for you. The first table is the group statistics table. In the first table, you can see salary is your dependent variable, gender is your independent variable, N is indicating you number of female and number of male. Then this is the mean male salary, and this is the mean salary for the, sorry, this is the mean salary for the females, and this is the mean salary for the male employees. So this is the mean value. This is a standard deviation for female salary, female employees salary, and this is the standard deviation for the male employees salary. Next one is the standard error. So standard error formula, I have told you, I think at the first day or at the second day, that with the help of standard deviation, we can calculate the standard error of the mean. How? Standard deviation divided by its respective underscore of sample size, means this value divided by under root of 216, this value divided by under root of 258, you will get the standard error. So this way you can calculate manually and check the standard error of mean. Now I think it is bit clear to you. This is the average salary and this is the standard deviation. This is indicating you the scattered nets or the spread in the female salary, and this is the spread in the male salary. This is the thing. And keep in mind one thing, standard error should always be less than the standard deviation, and this standard deviation should always be less than the mean value. So all these are perfectly matching the criteria. So this is the one thing. Now we are coming to the next table, that is the main table of independent sample t-test. Firstly, we need to check the last assumption. You can see in the first part of table, in the first few columns, you can see the Levene's test for equality of variances value is given, and it is represented by F, means it is a kind of ANOVA, because F is indicating you the ANOVA test. So Levene's test is a kind of ANOVA test. It is giving you value as 119.669, and for its the significance value is 0.000. So how we can interpret this? As per the rule of Levene's test, the null hypothesis is the variance of both the groups are equal. According to the significance value or according to the p value, we can say this p value is less than 0.05. Remember, we have set the level of confidence level as 95%. So that is why we need to compare this value with the help of 0.05, that is the level of significance. So this point 000 is less than 0.05, we can say that the p-value is less than 0.05. That is why we will reject the null hypothesis. And when we will reject the null hypothesis for Levene's test, then we can say that both the groups variances are not equal. So here you can see equal variances assumed, equal variances not assumed. So your test is indicating that there is that the both the groups variances are not equal, means we need to go here equal variances not assumed, means now we will check the result according to this particular row. Now there is no role of this particular row in your study. Now we need to move according to this particular row, and now we will move further and check the corresponding value of t. So corresponding value of t is -11 or -11.688, and its corresponding degree of freedom is 344.262, and its corresponding p value is 0.000. So this value is less than 0.05. That means we will reject the null hypothesis. And I hope you have the null hypothesis in your mind, that we have set the null hypothesis as there is no significant difference in the salary of male and female employees. So this particular hypothesis is rejected. So alternatively we can say that there is a significant difference in the mean salary of male and female employees. So this would be the conclusion of independent sample t-test. Further, there are few more columns, so we will see. First one is telling you the mean, next one is telling you the mean difference. Mean difference is same, you can see this is the difference. You will get this particular value from here, means when we will you will subtract the mean salary of the female from the mean salary of the male employees. You will get this particular value. So this is the one thing. Then the standard error of differences is, as this is the same thing as I've told you, this particular thing will be divided by the under root of n. So you will get this standard error of differences. Lastly, you need to see 95% confidence interval of the differences. So for last row, if you will check for both the values, this is the lower and upper value, means this is giving you the range. This is indicating you that there is no zero exist between in this particular row. That means your test results are reliable. If if zero exists in between this particular range, in lower and the upper bound range, then you can say your results are not reliable, means both the lower value and the upper value should be either minus, or these should be either positive value. So whatever results you will draw, that results will be the reliable results. So this is the first test I have told you. As we have seen that the assumptions are not met of the independent sample t-test, but for the sake of demo I have applied this parametric test. So now we will go for the next test. We will check the Mann-Whitney test, but before that I am coming to the presentation and will show you Mann-Whitney test first. We will discuss first, then we will move towards to the SPSS window to apply Mann-Whitney test. So now we will understand what is Mann-Whitney test. So Mann-Whitney test is the alternative of the parametric test, that is the independent sample t-test, means if any of the assumptions of independent sample t-test is not matched, it's not fulfilled, in that case you can go for the Mann-Whitney test, and that is the non-parametric test. In this particular test, generally the nature of both the variables should be ordinal, but as we have seen in the case of independent sample t-test, the nature of our dependent variable was continuous in nature. So it is allow you, means Mann-Whitney test allow you even when you have a dependent variable of continuous in nature. But in that case you need to see one thing, that the hypothesis of the test will get changed. I will discuss these hypotheses later. Firstly, we will see the assumptions of Mann-Whitney test. The first assumption is the independent variable is nominal or dichotomous, means it should be measured or either on nominal scale or on dichotomous scale. Second, dependent variable can be on continuous scale or on ordinal scale. Third one is there is an independence of observations, means both the groups which you are taking in case of independent variable, they should be independent to each other. And the most important most important assumption of Mann-Whitney test is the fourth one. It is telling you the distribution of scores in two groups have the same shape. Means whatever graph you will plot, they should, for male and female, they should show you the same shape. If they are showing you the same shape, you will go for the checking, you will go to check for the difference between the group medians. Otherwise you will go for checking of the difference between the mean ranks. Means your this is indicating your hypothesis. If the shapes in both the groups are same, your hypothesis will be based on medians. If shapes are not same for both the groups, your hypothesis will be based on mean ranks. Then here you can see this type of diagram. If you are getting, means first one is the identical, means here both the groups are, means this is the histogram for both the groups, male groups and female groups, but both are showing you the identical distribution. Means there is overlapping of male and female groups distribution. So this is the extraordinary condition. It is generally in day-to-day life or in daily life we are unable to get such type of distribution, is identical distribution in case of both the groups. But if suppose same shapes are getting by you in case of both the groups, so even then you can proceed for the Mann-Whitney test, and your hypothesis will be based on the medians. So what will be your hypothesis? I am showing you your hypothesis. When the shapes are same, there is no significant difference between the medians of the two groups, and alternatively you can say there is a significant difference between the medians of two groups. Or when the shapes are not same, then you will say that there is no significant difference between the mean ranks of two distribution, or alternatively you can say there is a significant difference between the mean ranks of two distributions. So this is depending, means your hypothesis will be depending upon the shape of the distribution. According to the shape of distribution, you will change this mean ranks or the median. Means you need to change this particular term, either it would be a mean ranks or it would be a medians. So this is the case. Now how we will apply Mann-Whitney test in the SPSS? So just I am coming to SPSS now to showing you. So now, as we are knowing this thing that our data is not matching the assumptions of independent sample t-test, main assumptions of independent sample t-test, that means we should either transform our variable or we should go for the non-parametric test. So now I am going for the non-parametric test. So what you need to do, you need to go to the analyze menu, then go to the parametric test. Again I am repeating, go to analyze menu, then select non-parametric test, and here you can select the independent samples. Analyze menu, non-parametric test, then select independent samples and click on this. A big box will appear in front of you. Here you can see there are three tabs. First tab is objective, and the by default selected option is automatically compare distribution across groups. Yes, we want this, and we will go with the by default option in case of objective tab. So we don't need to touch anything here. We are okay with it. Click to the second tab, that is the field tab. Here you need to define your test variable and your independent variable. So our test variable is current salary. So I'm shifting this variable to the test fields box, and then selecting the gender and shifting it to the groups box. Next, last one is the settings tab. Click on the settings tab, and here you can see there are two options available, that is the automatically choose the test based on the data, and second one is customize test. Means SPSS is knowing this thing when you have a independent variable and it has only two groups, so it will give you by default the result of Mann-Whitney test. If you don't want, if you want to tick by yourself, so what you need to do, you need to just click on the customize test, and then you can click on the Mann-Whitney U test for two samples. So this way you can do this thing also. Otherwise, you can only click on the automatically choose the test based on the data. So it will also give you the same thing. Then click on the run. As you will click on the run, the output of SPSS will generate you the output. So you can see here, this is giving you the output for the Mann-Whitney U test, but there is no distribution is showing by the output of the Mann-Whitney U test. So what you need to do, sorry, you need to just double click on this particular table. When you will when you will double click on this particular table, one more window, output window will appear named as model viewer. Here you would be able to see the distribution of the two groups. At the right hand side, you can see the histograms for male and the female, and with the help of comparison of this histogram for both the groups, you can say that the shape for both the groups are very similar. The peak, when we are talking about the peak or the highest frequency, you can say this is coming to the lower zone for both the cases. So we can say that the shape for both the groups, that is for the female and the male groups, is same. That is the one thing. So means our fourth assumption is we have checked, and when fourth assumption is checked, and when it is showing you that the shape is almost same, so we need to know this thing, that your hypothesis will be based on now medians. So what will be your hypothesis now? There is no significant difference between the median salary of the two groups, because we are checking the salary. So now this would be our hypothesis. But here you can see this is giving you the mean rank. That means firstly we need to do little bit more exercise, and firstly we need to calculate the medians, then we will check the Mann-Whitney U test. So for that, again I'm coming to the analyze menu, click on analyze, then click on compare means, and from here you can select the means. Again I am repeating, for calculating median for the groups, what you need to do, you need to come to the analyze menu, then click on compare means, and then select the means option. Now here we need to shift the dependent and the independent variable. So select your dependent variable, that is the current salary, and shift this variable to the dependent list box. Then select your independent variable and shift it to the independent list, and then click on the options button here. Clicking on the options button, you can see these statistics will be the by default by the SPSS, but we are not interested in any of these statistics. We only want to calculate median. So I have shifted all the items which are given by the SPSS by default to the back to this particular statistics box. Now click on the median and shift this to the statistics box, and just click on continue and then OK. So you would be able to see the median salary for the female group and the median salary for the male group. So now again we are going to the same output. Here we are again we are coming back to the modular viewer. Now we can compare our results. So as per this particular test or this particular output, you can see the significance value is 0.00, 0.000 or 0.000. So this is again less than 0.05, because level of significance is given 0.05. So when the p-value is less than 0.05, in that case we need to reject the null hypothesis, and we will reject the null hypothesis. One more thing you need to do, what type of or what scores or what statistics you need to report when you are going for reporting the results. You need to give the Mann-Whitney U test value, then you need to give the standardized test statistic value, and also the asymptotic significance value, that is the 0.00. This is nothing, this is only the p value. When the sample size is large enough, then in that case SPSS gives you the asymptotic significance value, and that is the p value which is based on the normal or the standardized test statistics value. So on the basis of that you need to report this value, and then we can, on the basis of these results, we can say that we are rejecting the null hypothesis, and alternatively we can say there is a significant difference between the median values of two groups. Okay, so this way you can say, if I'm talking about, as I have told you yesterday, that when your data is not normal or it is non-normal data, so what you can do, first you can do, you can transform your variable. That is the first way. Second is you can go for the non-parametric test. Third one, you can violate the, even of violating the assumptions, you can perform the parametric test. And the last one, that is the important one, that is the sensitivity analysis, means you can perform both the tests. So today we have performed the independent sample t-test as well as the Mann-Whitney U-test. So both the test results are showing you the same thing, means in both the cases your null hypothesis is rejected. So means either you are applying the parametric test, your results is showing you the same thing, and when you are applying the Mann-Whitney U-test, again it is rejecting the null hypothesis. And alternatively we can say there is a significant difference between the median salary of both the groups. So this way you can understand or you can perform the test, and this is your, depending upon you in what way you are dealing with the non-normal data. So I have shown you all this today. So today we have discussed the independent sample t-test, its assumptions. We have checked all the assumptions with the help of SPSS options, and then we go for the Mann-Whitney U-test, and in that case also we have checked the assumptions of Mann-Whitney U-test, and then we have interpreted the results. So this is all for the day from my side. Now if you have any queries, any query you can ask me.
Calculate the median.
Hello.
Yeah, you calculated the median.
Yes sir.
Yeah, after that you showed, but there it is still showing that mean only. The graph which is showing.
No sir, one thing I'm again showing you the same thing. Coming to the this, sir, by default
Yeah,
may I speak now? You're done.
yeah,
So sir, yeah. So sir, by default, the SPSS give you the main rank only. But that is why you have seen I have performed a little bit statistics or little bit exercise for you. We have calculated the median also. And in the output window, you can see the values. These median values are also indicating you there is a difference between the salary of the male and female. So when your shape is same, so you have to conclude your results on the basis of these median value, because that is the by default result of the SPSS. We cannot do anything on this case. But if your shapes are not same, in that case you have to report these things.
okay. So there is no correlation between, or there is no relation between this and median one. This graph will
No.
still rank.
No, sir, in both the cases, you will say one thing, that whether there is a mean rank, means whether you are framing your hypothesis on the basis of mean rank, even then the Mann-Whitney U-test value will remain same. This is the thing only, because the standard deviation, because the p-value is showing you the point triple zero, means which is the less than 0.05. So even in that case also, your hypothesis will based on the mean rank, and you will conclude the same result whatever you have concluded for the median.
Okay, thank you.
Yeah.
Hello.
Yes sir.
Ma'am, there is a one question. Ma'am, we have taken two options. One is we are calculating on the basis of median, and other when we are talking about the ranks. Ma'am,
Yes.
here the shapes of distribution is same. That is why we are using median. If
Yes
suppose the shape is not similar, then in that particular situation, what we are going to do?
sir, as I've told, I have given the previous answer would be the same, that this is the results of mean ranks. You can see there is a difference in the mean ranks as well. You can see there is a difference. Mean rank is 153 in case of female and 308 in case of male. That significance value will remain same in both the cases. You have to report the same significance value, same Mann-Whitney test value, and the asymptotic and the standardized test statistics means you will report all these three values even in case of mean rank as well. It is showing you there is a difference in the mean ranks as well. And then you need to report that shapes are not same. That is why you have applied the means you have taken the hypothesis on the basis of mean rank. Sir, I hope you got the answer.
Okay.
Yeah.
Hello,
Okay, ma'am.
ma'am.
Thank you. Thank you. It means in both the cases we will answer the same thing. Just we will explain that we are doing on the basis of rank or we are doing on the basis of median only.
Correct, sir. Correct.
Thank you. Thank you.
Welcome, sir.
Hello, ma'am.
Yes,
This is
ma'am.
Kaushik here.
Yes, sir.
Actually, ma'am, the last part, the Mann-Whitney test. Can you explain it a little more? Because connectivity at my end was very poor at that time. I couldn't
So I
follow,
need
but
to
I didn't
repeat
interrupt because
I need to repeat the interpretation, sir, or I need to show you how to apply.
just the step in the SPSS.
Okay.
The
Okay.
interpretation part is okay.
Okay. So I'm coming to the analyze menu. Sir, you need to go to the analyze menu, then go to the non-parametric test, and here you need to select the independent samples. I'm resetting this for you. And what you need to do here, three tabs are given to you. First tab is indicating you automatically compare the distribution across the groups. So yes, we want to compare the distribution because that is the assumption of the Mann-Whitney test. So we will go with the by default option here. So we don't need to check or touch anything here. Need to go to the second option or second tab, that is the fields tab. Here you need to shift your dependent variable into the test field. So click on the current salary and shift it to the test field. Then select your independent variable and shift it to the groups option or groups box here. This is the thing in the second tab. And lastly, you need to click on the settings tab. So when you will click on settings tabs, you can see here there are two options. Automatically choose the test based on the data, and next one is the customized test. So automatically choose the test based on the data means SPSS is unable to understand this thing when you are giving when you are not giving any instruction. Even then SPSS can understand this thing that you have supplied a variable that is called independent variable and it has only two groups. And we are already here in the non-parametric test, so it will by default give you the Mann-Whitney test. But safer side, if you want from your side, so you can go to the customized test button, and here you can select the Mann-Whitney test. And after this, you can just click on the run to get the output. So this is the way you can calculate the Mann-Whitney test.
Okay.
Sir, I hope you got
Thank you, ma'am.
yeah. Okay, sir.
Ma'am, can you tell me how to shift the entire data to after the explore menu?
Ma'am, I'm not getting your question.
Ma'am, can you tell me how to select the entire data to shift it to the next box? Uh, First we go to analyze button, uh, then descriptive statistics, then explore. After
Yes.
that, if we want to select the entire data, how can we do that?
Entire
Actually, I
data
was
means
trying.
entire variables.
Yes,
Okay.
I
Ma'am,
was trying. I was
okay.
trying yesterday, but it didn't happen.
Okay. So ma'am, why you want entire data in these box?
No,
Because
ma'am. Actually, yesterday's I was practicing, so this thing
so
happened.
ma'am, one thing you need to keep in mind, if you need to first decide your dependent and independent variable. Suppose current salary, beginning salary, month since hire, these are suppose your options are, these are your suppose I'm dependent variable, for example. So what you
Okay.
need to do, you need to select these with the help of shift button. You can hold the shift button and select these variable with the help
Okay.
of your mouse, and then click on this particular arrow to shift this variable in the whatever box you want to shift.
Thank you so much, ma'am.
Okay, ma'am.
Hello, ma'am.
Yes, sir.
Thank you, ma'am. It's a really nice explanation. My
Thank you,
question
sir.
is related to item analysis, ma'am. Sorry for the inconvenience. Question is not related to today's topic.
Okay.
Could you please explain split-off method, ma'am?
Sorry, sir.
Could you please explain split-off method, ma'am? Split-off method.
Sir, I'm not getting you properly. What do you want to explain me?
Yes, ma'am. Split-off method. Split-off method. I'm not audible, ma'am.
Sir, your voice is breaking in between, so I'm not getting you properly.
1 second, ma'am. 1 second. Now I'm audible, ma'am.
Yes, yes, I can hear you, sir.
Yes, ma'am. Could you please explain split-off method through SPSS?
Sir, I'm not getting you. Can you write the question in the chat box?
Yes, ma'am. Yes, ma'am. Definitely.
I think he is talking about split half method.
Yeah,
Of reliability?
Yes, ma'am. Reliability.
Okay. So, sir, what you want to how many means how to calculate that I want to show you?
Yes, ma'am. Interpretation.
So interpretation will remain same in case of all the reliability statistics. If you are getting the value greater than 0.7, then you can say your scale is reliable. Whether you are applying parallel form, whether you are applying split half, whether you are applying the internal consistency, whatever you are applying, your value should be greater than 0.7. In that case only you can say that your scale is reliable.
Okay.
Yes, sir.
Okay. Thank you.
Welcome, sir. Any more questions? Ajay sir, can we wind up now?
Yes, ma'am. Thank you so much, ma'am.
Okay, thank you so much, Ajay sir, and all the participants.
Okay, ma'am. Thank you.
Thank you,
And
sir.
take care, ma'am. आपकी तबीयत ठीक नहीं लग रही है. Please take care.
Okay, thank you so much, sir.
Thank you all participants.
Thank you so much, madam. Please take care of yourself.
Thank you so much, ma'am, for your concern.